Okay, so yesterday we graphed exponential equations. So this is that. So let's do that. When we started, we did 3 points, right? So if the base is 3, remember I kind of had this as my, how to just start these. I did 3 to the -1, 3 to the 0, and 3 to the 1. Okay, what is 3 to the -1? What do you do with negative exponents? On the bottom, 1/3. What does a 0 exponent do? 1, and 3 to the 1 is 3. Therefore, this coordinate was -1, 1/3. This coordinate is 0, 1, and then 1, 3. Okay, so I graphed those 3 coordinates. And then we have a shape. Remember, it is increasing. Why is it increasing?
Because it's bigger than that.
Because the base is 3, right? If the base is smaller than 1, then our shape is decreasing, but this is increasing. And what am I missing right now? An asymptote, because this side will go closer, 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 closer to 0. Okay, exponential. So we said we had the anchor point, 0, 1. That was what we called our anchor point. And the asymptote, do you remember what the equation of this line is? Y equals 0. And another point, we always did 1 comma base, which specifically here is 1 comma 3. Okay, what is a log all about? So remember how here exponent is the input and the result is the output. Now, in a log equation, this time x is the result and the y is the exponent. So what's happening with x and y? And remember what the name of that relationship is? What's the name of this relationship? They're inversing. Okay, does that make sense? Because here the x was the exponent, on here the x is the result. Here the y is the result, here the y is the exponent. They're switching. Okay, so the log, I'm using a base 3, so we've already used the base of 3. The log is going to have an anchor point of 1, 0. Got to switch the x and the y. What do you think the asymptote equation will be?
X 0.
Exactly. X is 0 now. And 1, 3 is now going to be 3, 1. Or on a general sense, it's always going to be base 1. So what does that look like? So there's the coordinate 1, 0. There's the coordinate 3, 1. So those were those 2 coordinates. And can we just do this third coordinate? What would it become? 1/3, comma, -1. So where do you graph that? Go 1/3 to the right and down 1. And then this is your shape. And I'm going to have a vertical asymptote. Okay, I think I'm going to also add one thing on this. Let's talk about the domain and the range. The domain and the range. Okay, on the exponential, what's the domain? How far left are we going to go? Negative infinity to positive infinity. Range, what's the lowest height of that graph? 0. What kind of bracket? Are you exactly 0 or close to 0? Round, because it's an asymptote, you're not exactly 0. You can't hit 0 to a height of infinity. Okay, on the log, what's the domain? What's the furthest left? 0 to infinity, right? Range, we're going to go down forever and continue up forever. Did you notice anything? Yeah. Does that make sense? What we know about inverses? The domain of one will be the range of the other. The range of one will be the domain of the other, right? Okay, here we go. First thing, identify the base. What's the base of this? Five. Okay, I'm going to just start everything. Exponential log, doesn't matter. I'm going to start it the same way. 5 to the negative 1, 5 to the 0, and 5 to the 1. I'm going to get 3 points always to start. Okay, what is 5 to the negative 1? 1/5. 5 to the 0 is 1. 5 to the 1 is 1. Okay, here's where it's different. How do I write the point because this is a log? I write 1/5, comma, negative 1. If this was an exponent, I would write negative 1, comma, 1/5, right? 1, 0, 5, 1. Does that make sense? Because now we're writing result, comma, exponent instead of exponent result. Okay. Now let's go to our transformation stuff. Okay, actually, no, you don't have to normally do this, but I said, okay, let's just graph this, and then we'll transform it. So I have the 1, 0, the 5, 1. So they're all kind of having that general idea to it. Are we okay with those 3 points? The shape, the asymptote? Okay, let's get into our transformations. What ABCD is that? That's an A. And what ABCD is that? A C. now, do you remember how to write your coordinate stuff? X plus 2, because I'm going to have to move right 2, and a y. Okay, here we go. I'm going to do all 3 x's here. So 1/5 plus 2 is 2 1/5. Some of you might have been in your calculator, 2.2. 1 plus 2, so that is an x of 3. 5 plus 2 is 7. Okay, now let's go through the y's. Negate the y, so this will be positive 1. 0 times negative is still 0. 1 times negative is negative 1. Okay, we're ready to plot those 3 points. Sorry, the last one is a little bit off your graph. Okay, let's actually, before I connect this, let's talk about our asymptote. What is this in just like a word sense? What is this 2 doing? It's moving right 2. Does that affect our asymptote? Yeah. So our asymptote will be there. The asymptote will have moved right 2. And that makes sense because I can see my points. And then that will be the connection to my point. Okay, does your graph make sense to you physically? Did it reflect? Because that negative makes it reflect like that. You see that reflection? And going to the right. Okay, ready? Oh, this is got no base on it. Oh, what's the secret? 10. So y equals log 10 is really down there. And I don't like how this is written. What's wrong with how this is written? It's not factored out. Your b has to be factored out. Remember that? So negative 1 is now out. So x minus 4. Okay, so now we have identified we have a base of 10. Can you get me your 3 points? It's always the same startup. So 10 to the negative 1, 10 to the 0, 10 to the 1. Okay, do we know what these are? This would be 1/10, 1 and 10. Exponent or log, start that way. Doesn't matter. But now how you write the points is different. So this is a log, so we need to go 1/10 comma negative 1. Right? On the exponent, you write it the other way around. 1 comma 0 and 10 comma 1. Okay. Are you okay that I don't graph the parent one and we just do the transform one? Is that okay? So let's talk about these transformations. Can you tell me those as a B, C, A, D, a B, and a C? So I'm going to go x divided by -1 plus 4. A B and a C. So still from last unit, what we're doing. Okay, there's my 3 new points. I'm not going to do anything to the y's, so I wrote the y's down. Okay, we ready? -1/10 plus 4. Anybody know what that would be? -1/10 and then add 4 to it. What's 4 subtract 1/10? 3 9/10. -1 plus 4. What's -1 plus 4? 3. -10 plus 4. -6. Are we okay to draw our asymptote first? Is that okay with you? Where should I draw my asymptote? Normally it's right here. What happened in my transformations? What's that say? Right 4. So my asymptote is x equals 4. Because sometimes it just says what's the asymptote. So if you ever ask what's the asymptote, it's x equals 4. Okay, so our 3 coordinates should hopefully make sense around that. Okay, we reflected it and we moved it right 4. Does it make sense? Do you know what the original would have looked like? Just if I quickly sketch it, you don't need to. That was my original. Did it reflect as a B reflection? Did it reflect? You see the shape reflected? And then right? Do you see it? I'm getting no head nods. Okay, last one. Okay, what in the world does ln mean again? Do you remember that? Natural log. I mentioned it briefly, I think, once. Do you remember the base number? It's actually a letter of the alphabet. E. Okay, so ln is a base of E. So I'm going to do the 3 things I always do. Those are the 3 things I always do. And I'm not expecting you to know this as a number. Okay, so a negative exponent is a 1 over an E. So this, I don't know, so I'm going to go into my calculator. Some of you maybe want to pay attention to how to do the E in your calculator. So 1 divided by, some of you have my calculator type, and some of you might be different. So my E, specifically my E is at the bottom on the here, so I have to push second shift that. And here's what I don't like. It automatically gives an exponent, so I have to go like e to the 1. Because mine does an automatic exponent, I don't know why. Okay, I'm getting a point 3, da 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 da. Who's not finding that button? Call me over to see what's going on in your calculator if it's... Okay, when you graph this, I'm not going to know the difference between a 0.367 or a point whatever, so just do a 0.4 because it's a graph. Oh, yeah, that's it. Okay, so I'm going to just do 0.4 because this is a graph. Okay, e to the 0, we don't have to do that in our calculator. What is the answer? 1. And e to the 1, so I'm going to do that in my calculator. E to the 1 is 2.7. Maybe just like pi, you'll kind of have that number memorized, and e is a 2.7-ish. So that's... Okay. What is the coordinate of the point, since this is a log, not an exponential graph? 0.4, comma, -1, 1, comma, 0, 2.7, comma, 1. So those are the 3 points I developed. Okay, I have to transform it though. I have an A and a C. So I'm going to go x plus 2 negative y. Okay, so let's do 3 new points. So again, always starting the same way and then figure out the next set of points. So 0.4 plus 2 is 2.4. 1 plus 2, 3. 2.7 plus 2 is 4.7. And then negate my y's. So plus 1, 0, -1. Okay, asymptote, I'm going to draw that first. So this was a right 2. So my asymptote should be at x equals 2. And then I'm hoping my points make sense based on that asymptote. So 2.4, comma 1. 3, 0, 4.7, -1. And that makes sense because there was a reflection over the x-axis, right? Because the normal log shape is like that. So now it reflected. That's what a reflection looks like, and it shifted right. Okay, that's it, I think. So I did those last two because it's at remembering the secret base of 10 and the base of E.